A very warm welcome to all of you, and thank you for your interest in our presentation. So at first, I'm going to introduce to you the other co-authors, Lucio Tirone from Fincantieri, that is also the other speaker in this presentation today, and Maria Giovanna Scognamiglio and Paola Bonofiglio. So in this presentation, in our paper, we would like to propose a rational approach for a decision making at the very early stage of a naval vessel design. And in this perspective, we have identified the methodology based on systems engineering. Next. We would like to share our proposal with you in this presentation that is made of 5 steps. A very quick description of such steps. So at first, we are going to tell you the reasons why we feel that it is necessary, this innovative approach. Then we are going to describe the approach itself based on the identification of capabilities, and we are going also to describe their taxonomy. Then, of course, we are going to discuss very briefly the kind of added value that can derive from this taxonomy of capabilities. And finally, we are going to share with you some final considerations and possible hints for future development. Next. So it is well known that warships are very complex systems from the technological point of view, and at the same time, their operational requirements can be very difficult to be translated in technology that we need to integrate on board. And at the same time, another great challenge that we have is to discuss as a whole what it is usually kept separated, so the payload, the payload, so the technology that we have mentioned up to now, and the so-called platform, so the vessel itself. With systems engineering approach, we think that we can derive some effective support in order to overcome the mechanicistic view, to separate all the items and to look at them in an isolated way, and to gain a perspective, a comprehensive perspective of the ship. This implies at first that the ship performance is to be observed as an emergent property. That means that the ship performance should be observed as a collaborative result of all the different parts that are working together. So not as a property of individual components, but as a property of the ship as a whole, made of the platform and the payload, as we mentioned before. Another very important advantage to, let's say, to implement this innovative approach is that we can also measure the ship performance in an innovative way, considering some tools that can be named as measurement of performance and measurement of effectiveness. And these are exactly terms that are derived from systems engineering. So as a starting point, ship capabilities need to be identified, and in our discussion are exactly considered the kind of emergent properties that we have spoken about up to now. And for the Warship, the emergent properties are the so-called design goals that in turn are the ones that can comply, that can fulfill the customer expectations. Next.
Thank you, Paola, and welcome everybody. I'm Lucio Tirone, and I'm going to present you the systems engineering process that will take us to the definition of the performance as has been described so far. The process presents a clear separation of the problem domain and the solution domain. In the traditional approach, we start from drafting the specifications of our ship, and so describing the performance and the requirements in document format. But instead, applying systems engineering approach, we have a whole process before that, because we start from analyzing the problem domain, which means understanding who are the key stakeholders involved in the Warship development and what are their needs. And after that, this is the step that we are describing with this work, we define capabilities that are requested from the ship. And from those capabilities, and with the close interaction with the user, who is the owner of the operational aspects of the ship, so the definition of the missions and the operational scenarios. So as I was saying, from the capabilities, we derive a number of performance measures. So MOE and MOP, those are measures of effectiveness and measures of performance. Only after we have done that, we move to analyzing operational level requirements, so requirements seen from the point of view of the user. Then we define the architecture, and in particular architecture alternatives for our ship, and then we close up on a design. And at this point, we are ready to develop the system requirements, so the system specifications. So the capabilities are actually the core of the first part of the design of a new ship. It is the point where we understand why we need a ship and what we mean it to do. And doing that involves generating a taxonomy of the capabilities. So this is a proposal that we have developed by analyzing a Warship, by defining it as a process, starting from a common platform that is floating on the sea and enriching it of functionalities, of high-level functionalities and so capabilities, up to reaching the level of a whole Warship. So, as you can see in those groups that are highlighted in this slide, we start on the bottom with the basic capabilities of any floating platform. So we talk about buoyancy, we talk about stability, and we talk about structural strength. Then, if this platform needs to interact with the humans, we will need on the left side safety and security. And if we want to use this platform as a ship, we will need power generation, controllability, and navigation. And then we come to the payload. It is a modern technological ship. So on the right side, we have, on the left side, sorry, we have communications capability and command and control capability. And on the right side, we have the part of the payload that characterizes a warship, which are surveillance and combat. This is the taxonomy we came up with, and I can describe to you shortly each of these. So we started from any platform that is able to be at sea. We need buoyancy, so it is the capability to float on the water and to carry a given payload. This platform needs stability. We need to avoid it capsizes and drops the payload on the sea. So we have a stability capability. And then we have structural strength, the capability to avoid falling apart. As you can see, we have developed a second level and sometimes also a third level of definition of this capability by identifying the different conditions, for example, which are considered on stability when we design a ship, which is stability in intact conditions and stability when some damage has occurred to the ship. So our taxonomy gets more rich as soon as we enter in higher detail on the study of a single capability at a time. Full detail, of course, on these capabilities are available in the paper. And I'm now moving to the second group of capabilities, those on the left. Safety. Safety, as you can see, is intended as preservation of personnel. So since we are using this platform as a tool, as a system, as an instrument for achieving some purpose, we need to make sure that no people are harmed by the usage of this platform. It can be people on board, it can be people on a dock, or it can be people in other ships. So that is preservation of personnel. We have preservation of property. We have to make sure that our platform does not infringe any other property or destroys or creates damage to other ships or other items. And of course, we have to preserve the environment. We have to make sure that no harm comes to the environment due to the operations of our platform. On the right side, instead, we see security. Security means that since we need to operate our platform, we have to make sure that there is nobody who can make an improper use of our platform with a malicious intent. So here we have the physical security, so preventing people to gain access or controlling what is happening around our platform, and electronic security, so avoiding that anybody can tamper with our platform. The next group of capabilities is turning our platform into a real ship. So no matter what we use, it can be oars, it can be sail, it can be an off-board engine or whatever. Our platform needs to sail, so we need power generation capability. Then we need to control that movement. We need to be able to define the heading of our ship, of our platform, and the speed. So that is what we call controllability capability. Then we have navigation. We are sailors on board of the platform. We need to understand where we are on the surface of the earth, and we need to be able to plan a route and to understand where we are in that route. So that is the capability of navigation. Following, as we said, we have a modern platform. We have automation in place. We have computers, actuators. They can be hydraulic, they can be electronic, they can be whatever. We have systems that allow us to control remotely the functions of our ship. So that is command and control capability. And then we have communications. We need to make sure that the crew can effectively interact with each other, transmitting orders and directions. And also we need to be able to communicate with other ships, with the shore, with the control centers, and so on. And that is the communications capability. The last one we are talking about is what makes a ship into a warship. So the warship is going to operate in a threatening environment in which threats exist against ourselves, so against the ship itself. There can be threats against another ship making part of our local task group, or it can be a threat against an area or even other interests. It can be a threat against political interests that need, for example, the ship to be present in a part of the world. So there are many types of threats. So in this case, we need at first the capability to discover, to locate, to analyze those threats. And that is what we call surveillance. And finally, the ultimate capability of our warship is the capability to neutralize those threats. It can be in a soft kill way, for example, by confusing the attacker and making sure we receive no harm, or it can be hard kill, which is effectively destroying the threat. So as you can see, we have developed 3 of different aspects of those 2 capabilities. So according to the different domain, we can have, for example, under combat capability, we have above water warfare and underwater warfare or electronic warfare. And then we can have, according to the range, close-in defense capability or short-range defense capability or long-range defense capability. So we have proposed this classification of all the different aspects. And the key point to understand is that we are in a very high level of abstraction. So we are not concentrating in solutions and in specific implementation. We are concentrating in what capabilities our ship as a whole has to be able to provide. And I pass back the word to Paola for describing interrelations among those capabilities.
Thank you. You have this comprehensive set of capabilities at a glance. Enables also a thorough discussion about possible mutual interactions and relations and dependency that we might have among them. Next. So, for example, we can observe that the surveillance capability can be enhanced, for example, by increasing the radar's height. But this has an implication in terms of stability, because actually we are going to have higher placement of weights that is going to have implication for ship stability in terms of the position, vertical position of the center of gravity. On the other side, for example, we can observe that a proper matching between a couple of capabilities can better help the fulfillment of the mission by means of the previous fulfillment of operational requirements. So, for example, surveillance together with controllability, so something that deals more with the payload, and controllability that has to do more with power plant installed on board and therefore speed, are very important to be matched in proper way in order to, for example, obtain the best performance in terms of patrolling of a specific area with some defined features. And these are just examples of many possible kind of further discussion that can be carried out during the early design stage. Next, please. What for? So it is very important to stress again that this kind of approach, this kind of attitude enables to focus on a very important part, that is the problem domain. So we are not interested at present to define alternatives. We are interested at present to better identify the problem domain, to better tackle with the customer needs and the operational requirements that the ship is should be characterized for. In order to do that, in order to put in action a process that enables this attention to the problem domain, we have identified a set of 12 capabilities, and that has been in some way described before, but that you can find better defined in the paper. We think that they are sufficient, and they are a comprehensive description in order to understand how to fulfill a superior mission by proper implementation of operational requirements that in turn are related to capabilities. We have stressed at the very beginning that capabilities are to be observed as an emergent property of the ship. So are considered a vision that enables the overcoming of the typical division between the platform and the payload. And this is a very, very important point. Next, please. So, a further added value of this approach is that in a very rational and systematic way it is possible then to define the kind of necessary technology that should be installed on board, being able also to taking care about their interface and interference issues that are to be framed and tackled with since the very beginning of the design. The next steps that are going to complete this innovative approach are the definition of proper measure of effectiveness and measure of performance, because they are the only way we have to appreciate the outcome of the design that we are developing, but in a comprehensive approach, able to look at the ship as a whole warship, as a comprehensive asset. Of course, this is just the first step, and we have identified which are the future kind of needs and steps that are to be developed, but we think that this is a very robust and sound approach in order to develop an innovative naval ship design process, able also to better fulfill the customer needs in a systematic and systemic way. So, from Lucio Tirone, that is in the Naval Business Unit of Fincantieri, and from Paola Gualeni from University of Genoa, that's all. Thank you very much again for your interest. Please, in case you need or you like to share with us your vision, your opinions about what we have proposed, you are very welcome, and you can contact us by email or by any other kind of platform that you like, and we will be very, very pleased to discuss with you. Thank you again very much.
E via. Interrompo registrazione.